Good evening. Welcome. Thank you for joining us this evening. We have people still logging in. I'm going to give it a couple more, maybe one more minute as people join the event this evening. All right. Well, welcome. Thank you for joining us this evening for this very important discussion about the plastic pollution crisis that we're in. My name is Robin Broder. I'm Deputy Director of Waterkeepers Chesapeake. And we're looking forward to having a discussion about the story of plastic, the film, and about the global plastic pollution crisis, but also our discussion tonight will be focused on the local plastic pollution crisis that we have here in our region. A couple of housekeeping things. This is a webinar, so attendees are muted. If you have any questions for our panelists this evening, please put them in the Q&A you'll find at the bottom of your screen, and we'll get to those at the end. When I watched the story of plastic last year, about this time last year, before the pandemic hit, actually, I walked away having all kinds of different emotions. I was pretty well versed in plastic pollution, but I learned a lot from the film, and I felt like there was something that I needed to do. So I hope you all have had a chance to view the film before tonight, but if you haven't, the link that was provided is good until February 1st. We'll put that link in the chat, and we'll also have a follow-up email with links to various resources and actions that you can take after tonight. But before we get started, I wanted to ask you all if in the chat you might just write some of your reactions to the film. What was your big takeaway from the film? Have you changed any of your practices when it comes to the use of plastic? So if you want to share those things with us tonight, we would really enjoy reading those. Waterkeepers Chesapeake is the coalition of all the waterkeeper organizations in the Chesapeake region, and includes the Potomac River Keeper. And a number of our waterkeepers are working on plastic pollution issues and trash issues. And I'm going to put a link in the chat where you can find some more information about the work that our waterkeepers are doing. So tonight we have, like I mentioned, the Potomac River Keeper. With us tonight, we have Dean Yowax, who has over 30 years of environmental nonprofit experience. He first started out as a river keeper in North Carolina as the Upper Neuse River Keeper from 2001 to 2008. And then he's moved over to be the Yadkin River Keeper and executive director of that organization until 2014. And in 2015, we were lucky enough to have Dean move up to our region and become the Potomac River Keeper. In 2020, he launched the Trash Free Potomac campaign. And if you follow him on Facebook, you probably have seen the crazy amount of trash that he has been picking up with a whole lot of help at the Oxon Hill Cove. And I'm sure he's going to talk about that. We also have Jesse Myler, who is a marine ecologist and environmental toxicologist at American University and in the environmental sciences department. She received her PhD at the University of Maryland in marine environmental sciences, and after doing her undergraduate work at Johns Hopkins University. Um, she is currently researching microplastics in tributaries to the Chesapeake Bay. And then we also have Marty Gray, who is the executive secretary at the Potomac River Fisheries Commission since 2013. Prior to that, he worked at the Maryland Department of Natural Resources Fisheries Service for 27 years. And he's currently co-chair of the Chesapeake Bay Program's Sustainable Fisheries Gold Team and vice chairman of the Atlantic States Marine Fisheries Commission's Striped Bass Management Board, and a member of the Chesapeake Bay Program's Plastic Pollution Action Team. So we will now turn it over to Dean to talk about his work. So Dean, you can unmute yourself and share your screen.
Hello, everybody. I thought Bernard was going next. I apologize. Yeah, I'm trying to share this. Why isn't it sharing? I don't know why my presentation's not sharing. But... Okay, there we go.
There we go.
That everybody. Well, I appreciate you on the call.
We don't see it now.
Yeah.
Oops.
So I appreciate everybody being on the call tonight. My name is Dean Nyax. I'm the Potomac River Keeper, and I'm trying to figure out my PowerPoint here. Why it's not sharing.
We had it for a moment.
I don't know why it's just not sharing. All right, why don't we just have Marty go?
And if you hit the back arrow and then hit the present button, yeah, just go down to the bottom right corner. There's like that little. Yeah, there you go.
There we go.
My biggest fear happened. Anyway, thank you, everybody. Nyax, Potomac River Keeper. I'm based right here in Washington, D.C. I've been a river keeper for about 20 years now. And, you know, this is my email if anybody needs to get a hold of me. You know, basically our mission is to protect the public's right to clean water and stop pollution to ensure a clean and healthy Potomac River. It sounds pretty easy, but I assure you it definitely comes with its challenges. And what we do as river keepers, we have 3 river keepers, one on the Shenandoah, one on the Upper Potomac. I'm based here in DC, and we work to protect and defend the Potomac controls. We conduct permit reviews. We investigate sources of pollution, impacting water quality, and we use these citizen provisions under the Clean Water Act to enforce compliance with clean water laws and eliminate sources of pollution. And we've had a long run, successful run of doing that on a pretty big level, sewage treatment plants. And we do this in a variety of ways. We do river patrols. We do aerial patrols. This is Dominion's Coal Ash Pond, 93 feet deep. We basically forced Dominion in 2019 to clean up 28 million tons of waterways. And this is a big coal plant that we're working on, challenging permits, eliminating toxic discharges of mercury. And, you know, these are things that we've had really a lot of success at. We just launched our Swimmable Potomac campaign in 2020. It's illegal to swim in DC. Really, it's the only US city that we're aware of that's illegal to swim because of sewage pollution. And basically our goal is to make this river swimmable again. And that's a big focus of what we're doing. And we have our citizen science volunteer water quality monitoring program. We have a tier 3 certified lab. Post our data every single week from May to October to let people know when it's safe to go in the river. And we're doing this in DC and Maryland. We're also working with Anacostia River Keeper in DC, monitoring a bunch of sites in the area. And really, our goal is to repeal the ban, let people know when it's safe to go in the river, when it's not safe, and then fix these combined sewer systems of both Alexandria's and DC's. And we've had a lot of success dealing with that recently, getting Alexandria's combined sewer system fixed. We're dealing with DC's system. And both of these systems should be fixed by 2025 Alexandria, 2030 in DC. But, the point is, and what this has to do with trash is that every time it rains, sewage and trash flushes into the river, right? By design. And it's a huge problem. And the good thing, though, with the combined sewer systems is these giant tunnels, which are going to be built 110 feet underground and capture all this stormwater and sewage and give the sewage treatment plant time to catch up and properly treat it. It captures a lot of trash too. And so there will be, at least in the DC area from the combined sewer systems, a lot of trash that's being removed and eliminated once these things have come online. The Anacostia Tunnel, which was built in 2018 and came online in 1 year, collected 7 billion gallons of combined sewage and stormwater, as well as about 2,000 pounds of trash. So that's good news. In some ways, the big issue here, though, is the effects of impervious surface on runoff. And there's a lot of information going on these graphics. The most important thing is just, I think, for people, you have a forested canopy, a forested area without impervious surface, only about 10% runs off the land. Most of it infiltrates or evaporates back into the sky. When you denude your landscape, build houses and parking lots and roads, the runoff rate increases to about 55%, from 10 to 55%. So now all this additional volume of water is moving off these impervious surfaces and carrying lots of pollution with it, and flushing out through our storm drains into our rivers and streams. And this is a really serious problem. It's a major threat to the bay cleanup. It's a major threat to water quality. And every time it rains, all this other stuff gets flushed off with it too. Pet waste, you have fertilizers, salt from roads, brake dust, anything that's in there, as well as trash. And so a lot of people, I've been doing cleanups for 20 years, and people are always like, I can't believe people are throwing all this trash in the river. And they don't realize that it's coming from the land. So we have the trash pollution we have in our waterways is also a stormwater pollution problem. And I'm sure many of you have seen these stenciling programs and all these storm drains. This is the requirement for most municipalities, that they have to try and educate the public about, oh, there should be no dumping in this storm drain, right? I mean, it sounds great. It's a good thing that people start to hopefully understand we shouldn't be dumping oil down here. But what I don't think people understand is that a lot of trash and other pollutants are going down these storm drains, and all this stenciling and everything we're doing, that's really the only requirement of these municipalities, is not getting the job done. And we're ending up with tons of plastic and pollution in our waterways. These storm drains, as you can see, are just sources of plastic pollution and trash. And so every municipality that has basically stormwater issues has an MS4 permit. And unfortunately, these MS4 permits don't trap trash, they don't deal with trash, and they don't regulate trash. And so all these stenciling programs and everything that you see to try and educate people isn't stopping trash and pollution from going right into our waterways. And so this is right here at James Creek Marina. Every time I walked my boat, I see this. And so I just became to a point, we just launched this Trash Free Potomac. I just couldn't look at this anymore. I couldn't look at this anymore and not do anything about it. Start trying to educate the public about where this is coming from, why this is happening. And Marty and Dr. Myler are the experts on this, and they're going to get into the science of this. But, we do trash cleanups, obviously, to engage the public on this important issue, because, so many people recognize that this is a serious problem, want to do something about it. We have 5 million people in the DC metropolitan area. So every stream and tributary that flows to the Potomac River is a conveyance. Every storm drain that goes to those streams is bringing trash with it. And this is Oxen Cove that Robin referenced that we've been working on the last couple of weeks, massive trash problems. And there's a whole nother story behind all this other bigger debris and trash. But this was just last weekend right here. So in 2 weeks, we've removed 109 bags of trash, 7,300 plastic bottles, 391 straws, 165 bottle caps, 62 lighters. I mean, 54 shopping carts, 42 tires. I mean, the list goes on and on. I think what's important is literally there's places around here where you're walking in ankle deep, shin deep plastic bottles. It's so bad. But even when you remove this is a before and this is an after here on the left. You can see if you look close enough, there's still, even with all the plastic bottles removed, tons of styrofoam and that smaller stuff like cigarette butts and straws and plastic caps. That's all just getting into these wetland areas. You know, these are critical habitats for, you know, all sorts of waterfowl, obviously breeding grounds for aquatic life that Marty can talk about. But, you know, this is a huge problem. And particularly in this area we have in DC, just some really big hot spots of trash. But the bottom line is there's so much trash that's going into the waterways that into the Potomac River, it's really hard to ignore. We have needles, plastic. This is my daughter, 50 bags of trash in one haul. Almost all that's plastic bottles. And as I started, after I watched the movie again last night, I started looking through these pictures and I'm realizing that almost everything we're picking up is plastic or petroleum based, like these tires and other parts, these orange barrels, these cones. A lot of this stuff is plastic pollution. And so I'm just trying to at least try to educate people that there's a direct connection between stormwater and trash in our waterways. I'll kind of wrap up with this is that you know, the Science and Technical Advisory Committee for the Chesapeake Bay program held a 2-day workshop that Marty was at and Dr. Myler. And basically they determined that microplastics in the bay and the watershed is an urgent issue that may affect restoration process, and it's warranting immediate action by Chesapeake Bay partnerships. And so, and they identified that storm drains are the major source of where this plastic, you know, and pollution is coming from. So I'm just going to put that out there that this is a huge problem. And as you can see from hopefully everything I've been presenting, all the work that we do as river keepers is based on science and law. And so we're struggling to find a legal hook to deal with this issue. But I can assure you we're looking for one. But more importantly, the science is clear. There's a real serious problem in our waterways of plastic pollution. And just on the bigger scale, less than 1% of all the water on the planet is available fresh water. And we just must change the way we view and use our water resources. This is absolutely, I know a lot of people understand the urgency of climate change, but our water resources and how we're dealing with it and plastic pollution. And I think the movie made a really good connection that these things are all connected. And this is a serious problem that I can no longer no longer ignore. And basically, we're the advocates, you know, the river keepers. You know, Marty and Dr. Myler, they're the scientists and they're providing us with the information. But we need to be, us and citizens need to be the ones that drive this home and talk to lawmakers and get them involved and start making change on this important issue. So I'm going to leave it there. Obviously, I'm open for further discussion after this, but I appreciate everybody taking the time. Dr. Myler's next, I believe.
Yeah. Jesse's next. Real quick though, before Jesse starts, Dean, we had one question that you could answer really quick. Somebody asked about what happens to the captured storm and sewage waste in the CSO.
Well, it gets held in those tunnels, and then once the sewage treatment plant catches up, it's able to be treated, and they separate obviously a lot of the trash that's in there and all the other stuff that's in there. But that's how you treat. That's the good thing about the combined sewer systems once those tunnels are built.
Thanks. All right, Jesse.
Hi, I was just trying to unmute there. Thank you so much, Dean, and I want to thank Robin and Dean and just Waterkeepers Chesapeake and the Potomac Riverkeeper Network for inviting me to be part of the event today. And then also for Marty and Dean for providing their expertise as well, because I think that it's all part of the same picture. So I'm going to go over some of the basic science behind microplastics and how it fits into this discussion. And okay, so next. So as you all saw, if you watch the story of plastic, there's a ton of plastic that's entering our waterways and ending up in the oceans. Actually, in 2010, there was a really comprehensive and interdisciplinary study that was published in the journal Science. It was published in 2015, but it estimated the amount of plastic that's going from land into the oceans each year. And that was looking at 192 countries around the world that bordered the coasts of the Atlantic, the Pacific, and the Indian Oceans, as well as the Mediterranean and the Black Seas. And these countries released or produced about 2.5 billion metric tons of solid waste in 1 year. And of that, 275 million metric tons of that was plastic. So from that, they estimated that about 8 million metric tons of plastic were entering the ocean each year. And that was, like I said, it was 11 years ago. And the reason I'm saying that is that most of the research up until this point has actually focused on oceans and marine environments as it pertains to plastics and specifically to microplastics. So even though the majority of the plastic is originating on land and entering freshwater systems before it makes its way into the oceans. So I started studying microplastics in the tributaries to the Chesapeake Bay. Next. The National Oceanic and Atmospheric Administration defines microplastics as plastics or pieces of plastic that are smaller than 5 millimeters in size. So they're pretty small, but the bigger end of that range you can actually see with the naked eye. And so they're broken into two different categories. There's primary microplastics, which includes tiny plastic pellets, as seen in the story of plastic, that companies manufacture, and they either make up, they're either used to make up or manufacture other plastic materials, or they're used in and of themselves, like microbeads that are added to personal care products like face wash and toothpaste and things like that. And then these microbeads that are in these products end up getting washed down the drain. And as Dean talked about, you have most of the, this water that ends up going into wastewater treatment plants, but some of it, if it enters combined sewer systems, actually ends up being discharged into waterways. The other thing is that because of their small size, even if they do make it to wastewater treatment plants, they often are not captured by filters and they escape and they make it into the waterways anyway. The other group of microplastics are secondary microplastics, and these form when you have larger pieces of plastic that enter bodies of water, and then natural processes in the bodies of water work to break up those pieces of plastic into smaller and smaller pieces. Some of those processes are like photodegradation and things like that, but I'll talk about that again in a second. But they break them up into microscopic pieces. Next. So as we can see here, this is a chart from the International Union for Conservation of Nature, where 28% of the primary microplastics, so those that are not being broken up from larger plastics, these are the ones that are actually manufactured to be pretty small, are from car tires. And some of most car tires today are actually either entirely or partially from synthetic rubber, made from synthetic rubber. And so as they wear down, small fragments actually can detach and be released into along the roadway, and then it rains and that gets washed off into waterways. Particulates also in urban areas can come from lots of different places. They enter the air. It might actually then be deposited out on the ground and can enter waterways as well. Next. The common types, these are just some of the common types of microplastics. And most of the time when we're looking at water samples, we are mostly seeing the microfibers that are dominating as the main type of microplastic. And then from there, we also see fragments sometimes and microbeads as well, but I'll get to that in a second. So there have been a number of studies that look at microfibers in waterways. And recently there have been some that have found that 90% of the microplastics that are found in oceans and other waterways are microfibers. And this was shown in a couple of different studies in the Atlantic Ocean, and then one that was done in the Great Lakes as well. Just recently, actually last week, there was a study that came out of the University of British Columbia that was published in the journal Nature, and that was looking at at microfibers in the eastern versus western parts of the Arctic Ocean. They saw most of them actually being in the eastern part. So they're thinking that they're actually originating from the Atlantic Ocean. And about 92% of all of the microplastics that they found were microfibers. And of that, 73% were actually polyester. So there's a strong suspicion that most of these microfibers are actually coming from laundry and textiles like clothing and things. So other studies have actually looked at bottom sediments as well in waterways, freshwater and marine both, and they've found that more fragments and microbeads actually are in the bottom sediments. And this is mainly because these are more dense pieces and they're going to settle out of the water column. And some of these samples actually have been found to contain tire particles as well, which was noted in a study that was done in the Chesapeake Bay, in the San Francisco Bay. Next. So if plastics are entering waterways from land, they're running off of the land down into storm drains during rain events and into creeks and streams and in our watershed, then what happens to the plastics once they actually enter the waterways? Well, like I mentioned before, this slide actually shows some of the physical, chemical, and biological processes that can act on the plastics. So you have sun and UV radiation that can cause photodegradation of the plastic, breaking it up into smaller and smaller pieces. You have chemicals that are already in the waterways that can react with the plastic, either causing it to break up into smaller pieces, or these chemicals might hitch a ride on the plastic to be carried downstream. And then you have biological interactions with the plastic, including microorganisms that can grow on their surface and be transported as well. Or you can have organisms that actually mistake the microplastics for food and ingest them. So these actually gets to some of the reasons why microplastics are a problem. Number one is they're becoming ubiquitous. They tend to be everywhere. And so, like looking at how microplastics can also contain complex mixtures of harmful agents, including sometimes PCBs or even pathogens. Also, microplastics can be digested by animals. They can actually be incorporated into organismal habitats. They can also be passed up the food chain with the potential to actually increase concern of hazardous chemicals that are entering humans as well. Next. All right, so now we have a little bit of background on what microplastics are. I just wanted to mention some of the studies that I've been working on very briefly. Next. The first one involves sediment and water samples that have been collected from Rock Creek and the Anacostia and the Potomac rivers around DC. And this was started as in an undergraduate class at American University about 5 to 6 years ago. And some of the undergraduate groups in the classes were collecting samples from various sites and comparing the sites based on land use and runoff. Others ended up comparing sediment and water samples and their concentrations of microplastics across different sites with the hypothesis mostly that there would be more concentrated microplastics in sediment that was due to separation, density separation, because they settle out of the water column. And they demonstrated this to be true, but they weren't necessarily looking for microfibers because, as I mentioned, most of those microfibers are actually in the water itself. Well, this grew into a much bigger research project where I'm working with my colleague, Barbara Balestra, who I think is on the call as well. And we are working with graduate and undergraduate research assistants over the past 3 years and focusing on one tributary to the Anacostia called Nash Run. And that's where we've been looking at both sediment and water samples. Next. Another study that I'll mention actually verified the presence of microplastics in brown bullheads from 3 locations on the Potomac and the Anacostia rivers, using electrofishing, working with the DC Department of Energy and Environment and US Fish and Wildlife Service, who were already collecting the fish. I was just able to kind of go along and look for, use the fish that they were already collecting to look for microplastics in the gastrointestinal tracts of these fish. And so we're looking at the lower Anacostia, the upper Anacostia near Bladensburg Park, and then the Potomac River near Dyke Marsh. And the majority of the microplastics that were found were actually from fish that were taken from the upper Anacostia near Bladensburg. Next. All right, and then the third has been a study that I've been working with my colleagues at Maryland Sea Grant, listed here on this slide, to observe and isolate microplastics within biofilm communities in the Inner Harbor in the Patapsco River up in Baltimore. And we've been looking at, essentially we put discs out in the Patapsco and we monitor them over several months, and we're looking for biological growth, biodiversity of what's growing on the discs, and microplastics. And this has been ongoing for a number of years. And we've been working with Maryland Public Schools in Baltimore City, Baltimore County, and Carroll County to implement curricula that we've developed on microplastics and biodiversity in waterways. Next. And so these are just, the next couple slides are just some pictures from what we've seen on the discs. And so early on, even before there was much of an established biofilm, we found microplastics on the discs. And here you can see some of the filaments and also a piece of foam. Next. These are some mudworm burrows that were seen early on after the discs started to be, you saw bacterial growth and then other organisms. So mudworms or whipworms were actually growing on the discs, and they were, this was before they were colonized by barnacles and later mussels. But you can also see a piece of plastic on here as well. Next. And then this slide just sees, you can just see some of the other organisms that we see on the discs to get an idea of the microplastics that are coming into contact with some of these organisms, some hydroids on the upper left here, an amphipod, and a mud crab. And then in the bottom left side, you can see Melisira there with a little, a red microfiber that was incorporated into the organisms. Next. So why we care about microplastics, like I mentioned before, you know, they're ubiquitous, and because we actually have been finding them in some of the food that we eat, in the water that we drink, and even the air that we're breathing. So there's been a lot of research that's been done to actually show some of the evidence in this area. Next. And adverse human health effects from microplastics in seafood may be caused by the plastic particles themselves or by additives that are adsorbed to the plastics, or I'm sorry, chemicals that are adsorbed to the plastic, or additives that are intentionally in the plastics themselves. Human uptake of microplastics from seafood, like from mussels or from oysters, really depends on how much seafood is being taken in, and then also how much microplastic has accumulated in the animals before they're actually eaten. And the digestive tract of organisms contains, so far, has been shown to contain the largest quantity of microplastics. And some of these images here show examples of microplastics in drinking water, sea salt, and even in beer. Next. In conclusion, microplastics are present in our waterways, in our sediment, in our fish, and in biofilms, which actually make up the matrix that supports aquatic and marine ecosystems. Some of the future areas of research that I'm currently pursuing with my colleagues is to identify some of these microplastics and hopefully to shed some light on the origins and their sources. We'll also be working to investigate the interface between chemical, physical, and biological factors that are involved in microplastics in the waterways, and hopefully expanding the biofilm work to DC waterways as well. Next. So with that, I'll finish up and I'll take any questions you have in the panel after the talks. Thank you.
Thank you, Jessie. And yeah, reminder, if people have questions for the presenters, for their panelists, please put your questions in the Q&A and we'll get to those shortly. And now Marty, if you want to unmute yourself and share your screen, that'll be great. Thanks.
So I'm getting the same message Dean was, host disabled. So maybe, let's try this again. Bernard, I'll go ahead and hit share screen. Oh, there we go. Hey, okay. Okay. All right. Well, thanks everyone for having me along. As Robin mentioned, my name is Marty Gary. I'm the Executive Secretary for the Potomac River Fisheries Commission. And I won't maximize this. I just have a couple of slides for reference and a couple of web tabs I'm going to toggle to for my discussion. But first, I want to thank both Dean and Dr. Myler for their presentations. Dean did a great job framing up the problem and the magnitude of it and the issues associated with it. And Dr. Myler put a nice overview to the technicalities of what we're dealing with to try to understand the scope and the impacts of these synthetic compounds that are ubiquitous in our terrestrial and aquatic ecosystems. So I was just going to talk a little bit about some fisheries perspectives. I run a little fisheries agency called the Potomac River Fisheries Commission. We've been around a long while, since 1963. That was when we had our first meeting. We were formed between a bi-state compact between Maryland and Virginia. Maryland owns the Potomac River. I'm going to switch here to a web tab. So hopefully everybody can see this map. And this map of the river, Maryland owns the Potomac River to the mean low water mark on the Virginia side. But in the
Marty,
1940s, and can everybody hear me okay?
Marty, we're not seeing the map.
Okay, I just switched. I'm seeing it. Let's try this. Looks like I've got to do this each time I toggle, but how about now?
There you go. Thank you.
Okay, sorry about that. And I may have to do this for a couple others. So this gives you an idea. This is the Potomac. Maryland owns the river to the Virginia side, the mean low water mark. But because of conflicts over the oyster resource between Virginia and Maryland in the 40s and 50s, the two states formed a compact to create my agency to co-manage the river. And my job is pretty straightforward as it's laid out in our compact. It's to protect, conserve, and improve the tidal fishery resources of the Potomac River. So our jurisdiction goes from the top of the screen up here at the Woodrow Wilson Bridge, all the way down to where the river meets the Chesapeake Bay. It's about 100 nautical miles. And we manage oysters, crabs, a variety of finfish species. Think of rockfish, bluefish, spot croaker, largemouth bass. Think about snakeheads, invasive species, and other invasive species like blue catfish. Those are the kind of things that I do. My day-to-day activities are involved with managing how many fish can be taken, how many crabs can be caught, that sort of thing. That leaves me with a pretty full plate. But other things impact my ability to conduct those activities. Dean mentioned coal ash. Leaving millions of tons of coal ash next to one of the most important spawning areas for striped bass on the Atlantic seaboard is not a good thing. So I found myself working with Dean on that. And the genesis for my interest in this, I guess that's the next step. And I may have to go ahead and do a new share here and apologize if there's an issue. Okay, and everybody's, am I back to the PowerPoint? Can you all see that? Or not?
Not yet.
Okay. New share. I guess I have to hit new share. Sorry about that. Okay. Is this little article, which was when I was driving home one day, I was listening to National Public Radio, and this was back in, I think, 2017 or 18 and 17. In September of 2017, this is what really piqued my interest in microplastics. I was aware of them, It got discussed a little bit, but it really wasn't on the radar for myself or any of my colleagues. But listening to this was an oyster researcher in the Pacific Northwest who was working with, I guess, a couple of different species there, Vancouver, in the Washington and Oregon area. And she was finding microplastics. And when I listened to this on my drive home, two things triggered in me. First is if they're finding in those oysters, there's a good chance they're going to be in ours. And lo and behold, well, that's what we found out, what we have come to find out. But also, in addition to the ecological impacts from this to oysters and maybe other marine life and other life in the Chesapeake watershed, human health impacts. And those are a couple of things that Dr. Myler touched on. So this was the trigger for me. So again, sorry for the awkwardness here, but let's try this again. I think I'm just going to have to, well, I'm just going to leave it at this one slide and go from there.
We see the Plastic Pollution Action Team page now.
You can see that. Okay. All right. Thank you. This is a little bit different from what I'm used to. I'm just going to kind of work off of this. So I sit on a group in the Chesapeake Bay program known as the Sustainable Fisheries Goal Implementation Team. And so we deal with a whole range of technical and scientific issues related to fisheries throughout the Chesapeake. And I brought this issue of microplastics to them and asking basically, is the Bay program doing any work? There's a whole array of different groups that are working on different things. And I deal with the fisheries group for the most part. So it was brought to my attention that there was going to be a STAC workshop, that stands for Scientific Technical Advisory Committee. So Dean touched on that, and he had one of his slides explain the findings of that. So when I found out the STAC workshop was being put together at George Mason University, right on the shores of the Potomac River, on the Virginia side, down below Mount Vernon, I was told, hey, Marty, if you're interested, you can attend this. So I did, and this was in early 2019. And the bottom line was I sat through 2 days of meetings with some of the most, some of the brightest people I've ever come in contact with. I live in a world of fish biologists, and I consider a lot of the folks I come in contact with to be really, really smart people. But I honestly was, pardon the pun, a fish out of water, working with these folks for 2 days, going through existing research on microplastics, what we do know, what we don't know, where are the data gaps. And I walked out of that meeting just absolutely stunned. So I took that information back to the conversations at the fisheries team at the Bay program. And lo and behold, the STAC proceedings, which Dean referenced earlier, were presented to the management board at the Bay program, which is one step below the governors and Mayor Bowser from the District of Columbia. So those are the executive committee. So the management board was presented with the findings of the STAC workshop. And to my delight, because I thought it was extremely important, I walked out thinking this is some of the most important work we could ever pursue. The management board blessed this work by creating the Plastic Pollution Action Team. And so they're looking to identify data gaps, try to help us better understand, as Dr. Myler said, how the ubiquity of these compounds is spreading and affecting the resources, living resources within the Chesapeake watershed. And they also are putting together an ecological risk assessment with a biological endpoint. And I was really flattered. They asked Marty, we're considering a few that, I think the public can really relate to. And so I got involved in the discussions with that Plastic Pollution Action Team. And you can see here, there's the STAC report and whatnot. But what I wanted to mention was it came down to a decision between conducting an ecological risk assessment, which is a modeling exercise using historical data, existing data, um, to determine what the impacts may be to a living resource. So it came down to choosing between oysters and striped bass. And the team was leaning toward oysters, and I'm really glad I was involved in the discussion, because I reminded them, though it's noble to look at oysters, and that was the genesis for my interest in microplastics. The fact of the matter is oysters are an incredibly low level of abundance based on their what their historic abundance was. In the Potomac, we're probably down to about 1 or 2% of historical biomass of oysters. And they're more or less clustered in the lower part of the river. So I told them what I thought might be more useful is to look at striped bass. As I had mentioned earlier, there is a stretch of the river above the Route 301 bridge that is known as a spawning reach. It's defined in Maryland Code of Regulations. It's a protected area, and it is the second most valuable spawning area for striped bass on the entire Atlantic coast. So that's an opportunity for this group to apply their modeling exercise for an ecological risk assessment with a biological endpoint for striped bass, and to look at the area from eggs and larvae up to, say, the 3rd and 4th year of their life history. Rockfish are a species that can live as long as 30 years, but those are the critical years of development. And so this is an opportunity to have a local ecological risk assessment. So they chose the Potomac River, and then they chose striped bass. So that delighted me, because those are 2 areas I'm very comfortable with. That's where my agency operates, and that's a species I'm very familiar with. So we went through that exercise, and then the PPAT is now, and I'm just going to toggle down since you can see this, and if I can find, well, I was going to try to find their next steps, but I will just leave it right there and just continue. I'll wrap up here in a second or two. So I guess the last thing I wanted to mention is, so we're involved with this, and I think hopefully what we're going to do is come back to the management board and characterize this, so we can then look at areas where we need to apply funding for additional research for folks like Dr. Myler and her colleagues and other folks to work in collaboration with people like myself to better understand how we're going to address the impacts that are existing now and how they go forward in the future, and better understand what we're dealing with in the academic community, the research community, and the management community. I think we're spending a lot of energy right now trying to understand the scope of what we're dealing with and the impacts of that. But we're going to need, it's going to take a comprehensive effort to address this, because as Dean and Dr. Myler said, these compounds don't go away. They just get smaller and smaller. And I think the two terms that have given me the biggest pause are trophic transfer, which Dr. Myler touched upon. That's ingestion of these compounds, and then they're transferred up the food chain. So it could start off with a zooplankton, an animal plankton, mistakenly consuming a tiny particle of plastic, which it thinks is phytoplankton. And then that's consumed by a larger organism and ultimately to fish. And so those are the kind of things we see. I'm going to try one more share and I'll wrap and turn it back over to you, Robin. See if I can pull this up. Actually, I think it's going to be the PowerPoint. Okay, so just today, I was sitting in on a Maryland Sea Grant presentation, and this was an excellent presentation. And it involved a species that does inhabit the lower Potomac River as a juvenile. But I just pop up this little summary slide here. They used this study species and they looked at all stages of the life history, the larval fish, the juveniles, and the adults. And the summary here you can see is it's the first study to evaluate microplastic ingestion in the black sea bass fishery verified that microzooplankton are important vectors of microplastics to larval sea bass. through trophic transfer, determination that microfibers have a negative effects on the physiology of early juveniles. So that's through respiration and also immune response. And it also is important to consider because wild caught adults ingest mostly microfibers. What it's saying really there in that summary slide is every stage of life history with that species is uptaking microplastics. And so then again, you look at the humans, if there's a commercial fishery for it, a recreational fishery for that species, that's just one example, but there's plenty others out there. And the talk this morning wrapped up, and I thought this was a really neat article that I had not seen before. It's not new. It was early 2020, I believe, published, Microplastic Occurrence and Effects in Commercially Harvested North American Finfish and Shellfish, Current Knowledge and Future Direction. So I gave it a quick skim this afternoon before I looked at it, but that's a great resource to inform folks of just how widespread the impacts are. So I'll leave it at that. I think the takeaway for me to tell you all is this is not in my job description to be engaged with microplastics. I don't have even 1/1000th of the knowledge base that Dr. Myler does on this, but it's really important. So I've diverted some of my time, and I'm fortunate that the people that I answer to, my 4 commissioners from Maryland and 4 commissioners from Virginia that are appointed by the governors of their respective states, have given me the opportunity to apply some of my time and energy to work on this topic. And I think others that I've come in contact with think it's also worthy. Plastics is going to be a huge problem. We're just now understanding it. And thanks to folks like Dr. Myler and a whole bunch of other people, we're really, really lucky. The good news is there's a lot of people studying this and trying to understand it, the impacts. And then we're also really lucky to have folks like Dean. I've been very fortunate to work with a lot of water keepers around the Chesapeake in my career. And I can say kind of selfishly that I think I have one of the best ever here in the Potomac. And so you saw all the good work that Dean highlighted in his talk. It's going to take everyone working together to try to address this. So I'll just leave it at that. Those are my perspectives from where I sit, and hopefully it's made a little bit of sense to you all.
Thank you, Marty.
I'm going to try to unshare unless you do that, Bernard.
So we have quite a few really good questions in the Q&A, and I think we'll jump right into doing that. First, I just want to comment that it's great to see the level of scientific research that's coming out of our region. I think there's a lot of I think our region is leading in that in a lot of ways, and contributing to the research on plastics and microplastics. It's really exciting to see. So I think I'll we had a couple questions, kind of COVID related questions. I think I'll put together and if and the panelists, if you want to jump in and answer as you see fit. One question was, are you seeing a lot more the single-use PPE and disposable plastic things in our waterways over the past several months during the pandemic? And then there was another question about, there was apparently on the news this evening, there was a segment about producing glass-covered plastic vials to be used with the COVID-19 vaccine. And have you heard about that? And do you know anything about their disposal? So Jesse or Dean, have you seen any uptick in PPE type?
Yes. lots and lots of gloves. Lots of gloves and masks too, but the gloves are what is going to stick around even longer than the cloth masks. So there's some of the masks that have plastic components on them. Dean, I'm sure you're out there seeing more than me.
Yeah, for sure. But again, a lot of like what I'm dealing with at Oxon Cove is just an acute, it's been there for years and it's just laying there on the banks. And unfortunately, it'll sit there for, several years and keep building up. And then we'll have one big, event, these big king tides or a big, semi flooding event, and it'll just pull all this stuff out in the river. And so it's just, it's an ongoing problem. A lot of this plastic's been there for quite a long time. And Bernard, if anybody wants to come out to Oxen Cove or clean up this Saturday or next Saturday, Bernard has the link, so you can put them in the chat if anybody's interested. We'd love to have you all.
Yeah, so we'll follow up with this information, and Bernard can put in the chat the signups for your cleanups, but I will also put a link to your events page on your website where you can find the cleanups that you're doing. And there are the other links. So, and so other questions that we have from the audience. One was about the microfibers. It was just a comment. Since you're finding so many microfibers in the does that mean that the plastic pollution in the film, which are not microfibers, merely the tip of the iceberg?
Well, I mentioned the different types of microplastics, and microfibers are just one of them. But when we're talking about the water itself, mostly what we're seeing in the water are microfibers, and that's because either they're buoyant or neutrally buoyant. They're in the water column versus the things that are more dense and are going to settle out. Doesn't mean that we don't find occasionally microbeads and occasionally fragments and pieces of plastic in there, but oftentimes that's because they've been kind of brought up from the bottom and suspended. But most of the time, those things that are more dense are going to settle out if they're given the opportunity. If they're carried with a strong current or something, they can still be in the water. And in the biofilm work that I've done in the Patapsco, and in other waterways too, those discs, all sorts of stuff settles out on it. So it's capturing what is actually in the water column, but still settles out of the water column versus just capturing the water itself, which is what Barbara Balestra and I have been working on the Nash Run, is mostly looking at the water itself. So it's different combinations of things. And yes, microfibers have been less looked at just because you don't necessarily you're not always seeing them unless you're looking for them. They're also, we know that they are entering waterways potentially from the air as well. So not just from runoff and things, but actually from the air also.
Thanks. So we have a lot of different questions that are all around the big question of what do we do? What can we do? So everything from what people can do in their own lives, what can we do through legislation, what can we do about different regulations, what can we do about enforcement? So that's the big question that a lot of people are asking. It's an urgent need. So if the panelists, Dean, maybe we can start with you. And talking about that question.
Well, obviously, we figured this question would come up, and I think the movie was really good at highlighting that the burden is being put on the consumer and not the industry. And somehow we must turn that, we must flip that. But as a consumer goes, we all hear reduce, reuse, recycle, right? And, I've practiced that for 20, 30 years. Marty and I have talked recently about refusing. We must start refusing plastic. When I go to a grocery store now, I absolutely will not let them give me a plastic bag. I don't care if I have to put it in the cart and carry everything out to my car because I forgot my bags, my reusable bags. I will not use plastic. We must start refusing plastic every way we can. Plastic straws. I won't buy plastic bottles. And these are just things, and it's taken time for me, like to tell my waiter not to bring me a straw. But if you start getting in the habit of it, it's actually pretty easy. And it's really not hard to just, start getting in the habit of these practices and building this into your life. But we got to we as consumers must stop using plastic, particularly single-use plastic, and the ones that we're seeing in the waterways and that were featured in the movie as having profound impact that we just can't do anything about. We got to stop that. There is some things, I personally think we need some national legislation, but again, we're up against multi-billion-dollar corporations. In Virginia, though, for example, the General Assembly created a Plastic Waste Prevention Advisory Council, which is supposed to make recommendations about dealing with plastic-related issues and plastic pollution. Unfortunately, the governor has not appointed the people to that council. And so it has been meeting, it has been making recommendations. And that's one of the things that I'm going to start working on, hopefully nudging the governor to start putting good people like Dr. Myler or Marty on this advisory council so that we can start getting these recommendations, that advocacy groups like us can start using this advisory council as kind of a tool to say, here's recommendations that came out of the Plastic Waste Prevention Advisory Council. We want legislation now, so there's opportunities like that. I know that Maryland is like banned styrofoam. They're working on that in Virginia right now. But these are just honestly some of the Band-Aid measures. And honestly, quite frankly, a lot of lawmakers don't want to go to the extent that's necessary. Some of the legislation that is being proposed is like banning balloons. I'm fine with it because it is causing a problem. But to me, we need to get at the heart of this issue, in my personal opinion. Every boater, every waterman knows that plastic bottles, single-use plastic bottles, are in our waterways and causing huge problems. So, I'm not as comfortable about moving toward legislation of banning balloons when it's like, disrupting a kid's birthday party, as opposed to, I think people realize that these plastic bottles and the stuff that's showing up in the oceans, that, plastic bags are the bigger problem. We need to do a lot more. But, honestly, even Fairfax County, one of the more progressive counties, has rejected a plastic bag fee. They don't want it. They said they don't have a plastic problem. And we need to start educating lawmakers and our board supervisors. And we just need people who care about this issue to start really putting pressure on them to start doing more about it. But there's a whole lot of things that we could and should do. And I'm just dipping my toe in this issue. And we're going to continue to work on this issue down the road. Marty, Dr. Myler.
Yeah, I'll go ahead and add to what you said, Dean. And I think you're right that the easy thing is things you have control of your own destiny. So if the refusal option you said, and that can only go so far, right? So the next time you're in the grocery store, take a look at how prevalent plastic is. It's pretty much on everything. And so I guess one thought that's been going through my mind, and fortunately I'm seeing some attention being paid fairly recently to this, is the production side of the equation, right? So the folks that are manufacturing this and the companies that are utilizing these manufactured products. And so discussions have to start happening, in those arenas. And it's a little bit out of my wheelhouse. I'm not afraid to try to venture out and try to help. But I think until we have choices, how are we going to be able to refuse, right? And Dean, you highlighted exactly. I do the same thing. I bring my own bags, or if I somehow forget it, I'll just leave everything in the grocery cart. But everything I've got in the cart still has plastic all over it. And then when I try to do the right thing, I have mixed use recycling in Baltimore County where I live. My understanding is it may not quite go where where it's intended to go when I put out my mixed. In fact, tonight is my night that I put out my mixed use recycling. But I've been told by folks that I know in Baltimore County government that it might not all get recycled. So it's very frustrating, and we need alternatives to the products selection that we have when we go to the grocery store. And that's something I've thought about, and I know others are thinking about, and not sure where we go from here on it, but it's an avenue that we have to pursue. But I'm with you. I'm like you. We can control what we can control, but we should be having discussions and exploring areas where we can, we have more options to our disposal. So those are my thoughts.
I would just tack on by saying too that, it is important to refuse when possible. And there have been some good points brought up in the chat about social justice issues as well with that. And also I would just mention access and resource availability and things. I hate to use the word but I think a lot of it is also packaging that Marty just mentioned, that is not necessary. And there are very, there are companies out there that are doing a great job in actually trying to either reduce or eliminate plastic packaging. And I think finding those companies that have comparable products, both in value and in efficacy, that you can afford is going the extra step to actually promote those products and those companies as well, being able to support them. And that I noticed some of the points of people saying in the chat about, using shampoo bars and conditioner bars and things like that, to avoid the plastic packaging there. But also just mentioning, like Marty saying, when you the shopping cart full of everything without the plastic bags covering it, but you buy the toilet paper that's covered in plastic, or you buy whatever it is, the packaging itself. And there are some countries and municipalities that have done a good job of trying to reduce or even eliminate the plastic packaging. And so I just think, that might be a way to go too. It's not just about the styrofoam bans and the plastic bag bans, the straw bans and the plastic bottle bans. And those are all really important too. I think these are all different pieces of the puzzle that have to go into it to try to find. And then I think that Marty or Dean mentioned finding, substitutes too, because there are some things that we actually do need a viable alternative to plastic for, that can't just be paper or glass or aluminum, which have a more useful and, to be able to recycle them is a little bit easier. They actually have a second life. But the reality is we have to think about the full life cycle of everything that we use. It's not just avoiding it. It's thinking about where everything we get is coming from, and the plastic components in it.
And order online. The one thing COVID, I think, has taught us all is there's plenty of opportunities. We started buying all our toilet paper from Who Gives a Crap, and it's all 100% recycled material. There's no plastic whatsoever. That's just one example. So I would definitely encourage that. But we definitely need to hold, plastic bottling industry and others that are creating these plastics accountable.
There was a comment, sort of a question about the fact that you're doing inventory of what you're finding in your trash cleanups. And I would add that quite a few organizations do that. Anacostia Riverkeeper does that. And do you use this data when you're finding solutions like passing legislation? And the answer is yes. I mean, that's primarily why they do it, but also, as you saw in the movie as well, that it can help with basically shaming corporations, trying to get to that point of corporate responsibility for the waste that they're producing. So that data collection is very, very important, and it is used. There was a question about, let's see here, let me scroll back up here, about microplastic pollution and wastewater management facilities. Do wastewater treatment facilities treat for microplastics, or do they just go right through the system?
It depends. It depends on the wastewater treatment facility. And it also depends on the size of the plastic. So I was talking about microplastics, a lot of the work, and actually Marty's point about the, the zooplankton that sees a little piece of plastic and actually thinks it's a type of phytoplankton that would be a food source and consumes that. So that's a really tiny piece of plastic. And the reality is that they go even smaller, down to the nano size. So much, much smaller. And so those are going to make it through any wastewater treatment plant, regardless of the filtration. So it depends on the size of the plastic, and also depends on the different types of filtration in the treatment plant.
And a question, just remind everybody, we will be sharing the recording afterwards, and numerous links to different resources, including Marty, two or three people are asking about that study that you referred to in your presentation, if we can get a link for that. It's somewhat related to the wastewater treatment plant question is, plastic eating microbes and bacteria that provide any hope for the future?
Dr. Myler.
I don't know a whole lot about them, so I can't really speak to that. That's out of my area. Sorry.
That's okay.
Yeah, I mean, usually, just in my experience, and there's probably people on here who know a lot better than I do. It's just that, if you're going to use biological activity to fix an environmental problem, it's usually like a concentrated problem like groundwater pollution. I can't imagine we have anything where, microplastics are so ubiquitous. I just don't see that as an option, for dealing with that problem where we have plastics and microplastics everywhere in our waterways and our oceans. We need to just cut it off at the source.
I'll just add, and not to try to attempt to answer that question because I can't, but I have found it to be a very valuable resource to use what they call science Twitter, right? So Twitter is famous for what we've gone through the last 4 years of hearing a lot of political messaging. But and Dr. Myler probably knows this, and I don't know, Jesse, if you're a user of science Twitter, but I found I couldn't tweet to save my life, but I found a lot of really fascinating information being exchanged by scientists, folks in your community that are doing the more technical work and analytical work. And if you go into Twitter and simply type in microplastics, you won't even believe the surge of information that's going to come at you. When we were in the STAC workshop for those 2 days at George Mason, I was one of the presentations that really struck me was Suzanne Brander, Dr. Brander from Oregon State University, showed us a live video feed of ciliate zooplankton that were consuming these little tiny colorful pieces of plastic that they presumably thought was a food source. That's what kind of prompted my comment. But I started following Dr. Brander on Twitter and then saw other people interacting with her. And I've accumulated a lot of good information just tracking these conversations that are happening there. And the good news that I've learned is there's an incredible array of individuals like Dr. Myler at a variety of universities all throughout the world that are studying this problem. So there's no lack of resources being applied to help us understand it better. The challenge, I think, is going to come when we find out the impacts and what we really need to do. How do we get to solve this hole we've dug ourselves into, where we're so reliant on it in our daily lives for everything we buy and everything we utilize. So I would just encourage you to go ahead and if you aren't a Twitter user, it's pretty easy to do because I can't tweet, but I can sure read these little quips, and it's fascinating. They link to all these journals and whatnot. The other thing I was going to mention is the STAC workshop paper that Dean referenced had over the span of 2 days, probably about 15 to 20 presentations. And again, it was one of the most powerful information dumps I've ever been exposed to in my life. And it was all really, really informative and good. And so the STAC workshop and all the links to those presentations are all on the Chesapeake Bay program website. So that might be a good source to double back to for folks that are looking for more information.
Hey, Jesse, I think a good question that came up was about biodegradable plastic.
Yeah,
Talked
and I've been seeing that pop up a lot too. Robin, is it okay if I chime in about that?
Oh, sure. Mhm.
So I will just mention about there have been a couple questions about biodegradable plastics, and I would just say that the terminology is tricky. So one of the things to keep in mind is that things that are called bioplastics, just because, so the way that plastics are made is that they are they're chains of what's called monomers, and so it becomes a polymer, which makes it really it ends up having all of the really cool uses of plastic that we want, right? Like things that are durable and they're going to stick around for a while. And so when you make bioplastics, you're essentially using, and the reason that we are, and if you watch the story of plastic, you learn that almost all the plastics that we use are from petroleum sources, right? So from the petroleum industry, it's one of the byproducts that can actually be turned into plastic. And so there's a very strong connection to the petroleum industry because of that. Bioplastics can be made from plant material. Lots of different kinds of plants can actually be used to make bioplastics. But if you're actually making it into long chain polymers, you're still going to have the same components, the same characteristics of the material. And so whether or not it actually breaks down, and that's why I chose my words carefully when I was showing the slides, is because I usually use the terms break up into smaller pieces, because they're not going away. They're just breaking up into smaller and smaller pieces. Whereas the terms break down implies that it's going to go away at some point, right? And so we're just being, careful about the different kinds of plastic out there. Some are biodegradable, and there's been a lot of work that's being done on different sources, including hemp being used as a source of biodegradable plastics that can be used for all sorts of different things that we would think, like even in the medical industry, and things that we actually do need that kind of like tubing and things like that, that we do need plastics for. And so there is a lot of work being done there, lots of different kinds. Some are better, some sorts of plants are better for making biodegradable plastics than others. And so I'll just stop there. But yeah, there's a lot of work being done in that area.
Thank you. I have a question that I think will go to Dean. About wouldn't a TMDL for litter or debris help make a difference, or at least give teeth for enforcement for localities? And along with that, I'll add a sort of another question, because you mentioned in your presentation about MS4 permits and whether or not that can be a way to get at this problem.
Well, that's a great question. I'm curious who asked it, but you're basically reading my mind. I mean, the MS4 permits, like I said, I mean, until trash becomes a regulated pollutant, and MS4s are actually required to deal with that issue. I mean, basically their permit says that they have to meet like this checkbox. They have to educate the public. They have to do street sweeping. They have to make sure like organic material like leaves are not put on the curb. So, but it's not about point source reduction or making sure that pollution never enters the waterway to some degree. I mean, there is illicit discharge detection, but anyway, I don't think MS4s right now are, I think they should be perfectly blunt. I think that they should. I want to start looking at ways to do that. As far as the trash TMDL, we've been looking into this. There's only 3 trash TMDLs in the entire country that I'm aware of: Baltimore Harbor, the Anacostia River, and the LA River. And none of them really implemented with a baseline. They said, oh my God, we got trash issues. And then they put in this TMDL, this total maximum daily load, which is like a pollution diet for a waterway. And they're after it's waterway, like the Chesapeake Bay has been identified as impaired from sediment, phosphorus, and nitrogen, right? So now all these states are now looking at ways to reduce sediment, nitrogen, and phosphorus, developing a prescriptive cleanup plan to eliminate and fix the unhealthy water body, right? So we need to, if we're going to get a trash TM down, we're going to do it successful. We need to get a baseline, which then requires, well, how much trash is coming into this so we can develop a real diet to cut back and say, this is only how much trash this water body can handle. And that's a challenge. We're looking into it, but like we basically need, like somebody had asked about quantifying the numbers and totals, but that's essentially what we need to do is get a trash trap put in place and then start quantifying the data. But a trash trap, I've looked into it, they're like $500,000. So it's really difficult. We have one in Fairfax County and they put it all the way up in the headwater stream of Little Hunting Creek, and it's not collecting any trash. So what I'm trying to do now is move that thing downstream. I'm running into all this bureaucratic red tape with the county. They don't want to move the thing because they've spent all this money to install it. So there's just all these hurdles in the way, but we're undaunted. We are going to keep trying to figure out a legislative and if not a legal path to start dealing with trash and pollution. And because honestly, I do think there is some burden on these municipalities. If they start feeling the pressure, then hopefully they'll start looking to state lawmakers and hopefully the industries that creating this plastic problem start helping deal with the pollution issue. I mean, I'm sure most people are aware that there was this big article in the New York Times that came out recently basically admitting that plastic recycling is a hoax, that it's failing. China now is no longer, in Taiwan are not taking our recyclable materials. In Fairfax County, we're not even recycling glass anymore. So recycling is failing and it's a scary thing. And I think this may be actually an opportunity if lawmakers start seeing that these municipalities and local governments and counties are having to pick up the tab and start dealing with this pollution crisis, this recycling crisis, by creating more landfill space and dealing with that problem, then maybe we can start focusing the attention on the creators of this problem. But that's a long way to go. And Potomac River Keeper is going to start working at a local level and start trying to drive this issue up. And that we're just at a starting point now. So great question though.
There's, we've already mentioned this a few times and Dean's mentioned this some, but there is in Virginia and in Maryland, there have been a number of different bans or taxes on different plastic containers, and DC as well. Virginia last year passed a bill that allows localities to have a tax on plastic bags. So now it goes to the counties to whether or not they're going to do that. And then the pandemic hit, so there's been a reluctance to do that. There's an effort Dean mentioned this, an effort in Virginia to reduce or ban styrofoam, and that would be phased in for food service businesses, for food containers and things like that. In Maryland right now, there's a bill for a statewide ban on bags. And last year, Maryland banned foam containers, food containers. So there's a lot of different things going on the state levels, and some localities, some counties, some cities have also done their own things, in Maryland in particular. But there needs to be something on the federal level too. When you want to get to things like when you're asking, there were some questions about how do we get to the question of holding the corporations accountable for the waste that they're producing. As the movie was talking about, it's not really a question of people aren't demanding this stuff. It's more of a question that they're producing this stuff. And so we need, so there needs to be some accountability for that, especially on a global level. I mean, what some of the corporations do here or in Europe is completely different than what they do in other countries. And so that's a huge question, a huge issue that has to be addressed on a federal level and international level too. But I think efforts on the local level starts pushing those further up the responsibility chain, I guess you could say. And it's what we do on the local level is extremely important, even with these huge issues. And it can drive change on the federal level and other levels. So we're winding down. We have a lot of questions. Sorry we couldn't get to all of them. I'm just skimming through here to see if there's anything that we might want to jump on real quick. But maybe I'll just ask the panelists if there are any last thoughts you want to leave with us tonight. And as I mentioned before, we will be following up with an email to all the people who registered. And we're just going to bombard you with resources and things that you can do and actions you can take.
Yeah, Rob, and I was looking at the chat box, and one item caught my eye, and I think we take it for granted, but there was a comment made about that there's a window of opportunity opening, and they're alluding to a political window of opportunity. We now have an administration that's just taken over that is going to address climate change, and a key part of that is our reliance on fossil fuels, which we've already tied into this equation. So there's maybe an opportunity for a nexus there to, while we're going down that pathway, to address that. And you can't take these opportunities for lightly. So between the whole climate issue and fossil fuels, there's also the sustainability component to this. Kind of trying to get them to patch together somehow. This is where it's kind of way above my head as to how politically that manifests itself. But I thought that comment was right on, and we just have this incredible opportunity now here, at least for the foreseeable future, for the next few years. And I know from a personal level, I think what's attainable for me is to continue to track the local actions of all of our scientists here in the Bay watershed, including Dr. Myler, and as this plastic protection action team creates its final product and brings it back to the board, I'm very anxious to see where that conversation goes. So those are my last thoughts. I know there's a lot of people that care. A lot of folks are on this Zoom call tonight, and I think the energy is there to do something positive. So my glass is more than half full and hopeful.
Yeah, I'll just briefly touch on that. I mean, Joe Biden promised to eliminate subsidies for fossil fuels, and I think we need to hold him to that because, to me, if we, this industry is teetering, and the movie, I think, did a great job of highlighting that. They're realizing their days are numbered. Renewables, global investments in renewable energy have already surpassed investments in fossil fuels, and that will never change for the rest of time. So this industry is now trying to find a way of forcing plastic on us and, sustaining itself for another 20, 30 years. And if we just hopefully start crushing subsidies for fossil fuels and make them compete in the real world the way they should with renewables, then hopefully we actually have a chance at dealing with both issues, climate change and plastic pollution. Dr. Myler.
Yeah, I will say that there's I'm one of many scientists that are working on plastics issues, and so I think that and many people are involved in communicating and getting that word out, like Marty was talking about, and trying to share what's going on, not being holed up in a lab, but actually trying to talk about it and explain what's going on and what we're seeing. So I think that that's a big part of it, and communicating, and events like this, and awareness. So I love the outreach component, and thank you to Waterkeepers Chesapeake for doing this, and as many more of these kinds of things that we can do to try to to get the word out. And it'd be great if everyone that attended was able to share this, something that you learned with somebody else, and to actually try to affect change that way. So I think that it does come from both the top and the regulatory side at the national level is really important, but also from the bottom up and the grassroots, and trying to make sure that, awareness and individual actions do actually make a difference. So it needs every angle. We need to get at the issue from every angle. So I really appreciated all of the questions today, and thank you to Robin and to Waterkeepers Chesapeake for inviting us today. Thank you.
Great job, Bernard, too.
Well, thank you so much to Jesse and Marty and Dean, and to everybody who logged on tonight on this very important discussion. And as Jesse said, that there's lots that everybody can do, and we just keep working on it. And I think we'll say goodnight. It's 8:31, and we'll continue this conversation some other time. Thanks so
Have a
much.
good night. Come out to our cleanups. Take care.
Thanks, everybody.
Take care. Thank you.